the session 3 resource person on mathematical foundations. Dr. Bindhu Madhuri Madam is a HOD IT department at JNTGV College of Engineering, Vijayanagar. Also, she is a hostel in charge of JNTGV College of Engineering, officer of hostel in charge. Thank you, ma'am. Thank you very much for accepting our request. Please welcome, ma'am.
Thank you, ma'am, for giving this opportunity. Hello, everyone. A very good evening to one and all. First of all, I'll thank the university authorities for giving this opportunity to be act as one of the speaker of this today workshop. So I'm very excited to talk to you today about the importance of mathematics as a foundation in many areas of learning and problem solving. Mathematics is not just about numbers or formulas. It's simply about thinking logically and how well you are going to analyze the patterns, and if you want to solve the problems, so how you are going to solve the problems in a proper structured way. So why mathematics is that much of important? So generally we could able to say mathematics is a universal language. Mathematics, we could say that mathematics is a language that everyone in the world could able to understand easily, whether you are solving a puzzle or designing. So if you are belongs to computer science, we'll say that solving a puzzle or providing a problems to generating applications. And if you are some other like a mechanical engineering student, then you are going to design a bridge. Wherever, mathematics always helps us to communicate our ideas clearly and accurately. And so as we are using the mathematics in our daily life in a practical, that is when we are budgeting the money. And so if you are working in a kitchen, so measuring ingredients in the kitchen, and even planning for your schedule, where not, so you are going to use mathematics in different ways. So we could able to say math makes the life much more easier. So can we say is that is only the thing that we are going to do, and it is not the thing that foundation for other fields that we are going to use. Mathematics is nothing but science uses the maths to understand the nature, and technology uses the maths to build the tools and applications. Engineers uses maths to create the machines and structures and buildings, and whatever the career that you have been chosen, math always will help us. So and one more thing that I want to say is not yes, I'm not a mathematical I'm not a mathematic teacher. I'm not giving that focus on mathematics and all, as I'm an IT. I'm a faculty of IT, and we are working, many of us are working with the machine learning and deep learning, and we are in the era of artificial intelligence. So we must have the fundamental concepts of the mathematics, whatever we have been learning from the childhood to now. So everywhere we are using the mathematics. Whenever you have been entered into the engineering field, what we'll think is, so in the first year only we are supposed to learn the mathematics. Later on there is no need of the mathematics. No, it's not at all correct. So whenever you are going to use a computer, always it will the foundation for a computer is some mathematics is the main foundation for our computers. So what we could able to say is nothing but math always teaches us to break the problems into a smaller parts, and how to analyze them, and we are going to find our best solution among them wherever. So mathematics always comes into picture. All these skills are valuable everywhere. So not in exams only for getting the marks and getting pass in the exams, no, but in real life also we are going to use them mathematics, as I said earlier, that budgeting your money, measuring ingredients in the kitchen, and we are going to plan your schedule, where not you are going to use the maths. So when we are going to main focus of this concept is nothing but always you are supposed to talk about the numbers, operations. So why we are supposed to go for numbers and operations are nothing but these are the building blocks of all maths. Numbers and operations are the building blocks. We could able to say these are the building blocks of all mathematics, and understand them. So it understands us well. So how we are supposed to go for it. And in the previous session, you may heard about pattern, the term called pattern, and so patterns and logic. So how we are going to do again mathematics always comes into picture. So the patterns and thinking step by step, how well you are going to do, so that we could able to get a proper answer to the particular one. So wherever we are going to use, so in a daily life also we are going to use mathematics. So today we are going to discuss about some of the fundamentals of the mathematics.
Yes, ma'am.
1 minute, madam. Is that is getting shared, madam? Screen is getting shared?
No,
Madam,
no,
is
no.
my screen is sharing?
No, 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 no.
No, ma'am.
Now,
Yes, ma'am. Yeah. Yeah.
So this is the mathematical foundations for a computer programming. Today I'm going to discuss it unlocks the power of mathematics to become a skilled computer programmer. In this presentation, we are going to explore the essential mathematical concepts that are from the foundations of a computer science, from number systems to the data structures, algorithms, problem solving strategies. You will gain a solid understanding of a mathematical foundations, which is going to empower modern software development. So I'll welcome you all to join this journey to unlock the power of mathematics and transforms our way to approach to the computer programming. So what is a computer programming? First of all, we'll go with, so that will be the communicating with the computers, so creating a software and logical thinking. So what do you mean by communicating with the computers? So that is a programming. So whenever if you want to communicate with two people, the communication always done between two people only. So if I want to perform a communication with other people, so there we are going to use a specific language. So the language is the thing that we are going to communicate with each other. Here also, when you are going to communicate with the computer, always you are supposed to have the language. That language will simply call them as a programming. With the programming only, we are going to communicate with the computer. So programming is the art of the providing clear step-by-step instructions for the computers to execute the tasks and solve the problems. This is how we are going to communicate. So how well we are going to communicate with the computer? With the help of the programming only we are going to communicate. So when we are going to talk about a language, so generally, so I know if I know the language Telugu, if to whom I am going to communicate with the language, the person, he also knows Telugu, then we could able to understand clearly. If I know Telugu, but he cannot able to understand Telugu, then what we are supposed to have? We are supposed to have a translator who is going to translate our language to his language and his language to our language. In computer science, we are always talking about three different levels of languages. So we are going to say high level language, low level language, and a middle level language. So what will be the high level language is nothing but the people, the users who could able to understand that languages, we are going to call them as a high level language. And what will be the middle level language? Middle level language is the, we could able to say that it will be a pseudocode, or it will be a middle level language that will be in the form of a assembly level language, which is not completely a high level or which is not completely a low level language. So a computer can able to understand only one language, that is nothing but a binary language. We could able to say that one as a machine level language. So what is the binary level language? And that will be in the form of only zeros and ones format. So after that, when we are going to communicate within the programming, and if we want to create a software, so the programmers uses again the programming languages to write the code in the form of the foundations of all digital applications and the systems. That is when you are going to write. So which programming language we are supposed to have? As I said, the languages are of three types: high level, low level, and a middle level. So high level, low level, and a middle level. When you are going for a high level language, that the human can able to understand only the high level language, and low level language that the computer only can able to understand the low level language. Then there must be a translator who is going to convert the high level language to a low level language and low level language to a high level language. Then we are going to take, as I said earlier, there must be a transformer which translator which is going to convert high level to the low level and low level to the high level. Then we are going to talk about three different things. That is translators. So translators lo vachinappudiki then you do have a compilers, interpreters, and assemblers. There will comes under there will be three different types of translators that we are going to talk about. So that is a compiler. What is the work of a compiler? A compiler is going to convert a high-level language program to a low-level language program. What is a low-level language program? Is nothing but a mission understandable language. What is the mission understandable language? That is nothing but zeros and ones. High-level language program is nothing but the users, that is we, the humans, they are going to write the language in their own language that understand by only the humans. The mission can understand only the mission level language programs. There we are going to use a work of a compiler or interpreter or the assembler. So all these three we are going to call them as the translators. So compilers and interpreters, that they are going to convert high level language to a low level language only. But what is the difference between compiler and interpreter is the compiler always compiler converts all the program at a time into a mission level language program. When it comes to a interpreter, it is going to execute step by step, so that if any errors are there, we could able to identify that particular one. I think nowadays everyone is using Python. So Python is a interpreted language. So, and high level language, what is the best example for high level languages? Simply we could able to say C is a high level language program, C++ is a high level language program. And we do have C level, Java is a high level language program. Like that, we do have different programming languages which are with the high level language. And as I mean, from the first session, we have been started with design thinking. So here, thinking always plays a vital role. So here, as a programmer, what you are supposed to have is nothing but a logical thinking is always plays a vital role if you want to become a computer programmer. So programming requires a disciplined analytical mindset to break down the complex problems into a manageable and a logical steps. This is what a computer programming is. So when we are going for in-depth of introduction to the computer programming, first of all, we are supposed to understand the algorithms, mastering with the data structures, and applying the programming principles. All these are very, very important to become the computer programming, computer programmer. So in understanding of algorithms, so before going for understanding of algorithms, so we must know what do you mean by an algorithm is. So how we are going to define an algorithm is nothing but the sequential steps that you are going to follow.
Madam, sorry to disturb you,
the sequential step that you are going to follow to solve the particular problem, that we are going to call them as an algorithm. So in understanding of algorithms, what there will be is nothing but you are going to explore the concepts of algorithms, including their structure, logic, and efficiency. Learn how to design and analyze the algorithms to solve a complex problems effectively. And when we are going for the mastering of data structures, that is nothing but data structure. So every time, as we are in the era of AI always dealt with, AI as AI technique, we do have the techniques of AI is nothing but a machine learning technique. So when we are going to talk about a machine learning always deals with the historical data. So the data is always matters. So data structure. So what do you mean by a data structure?
Yes, ma'am.
So delve into the data. So we are delve into the data structures, the structure of a data. So how you are going to store the data? So whether you are going to store the data in which format? So in which format you are going to store the data, that is in arrays or a linked list, stacks, queues, trees, that we are going to see. So how you are going to, what are the data structures and how you are going to store the data. And finally, we are going to apply the programming principles. That is, you are going to apply the fundamentals of the programming principles. That is nothing but you are going to have as it is an object-oriented programming, if it is the procedural-oriented programming, always you are supposed to follow a specific procedure to follow it. So the main objective of this session is to understand the importance of the mathematics in computer programming. So you are going to learn the key mathematical concepts used in programming and build a foundation for solving the computational problems. These are the main objectives of this session. So what is the importance of mathematics in programming? In normal way, while I'm starting the session, I have been given a simple glimpse about in daily life, how well we are going to use the mathematics. So, but here we are going to have a mathematics in programming, how we are going to use, where we are going to apply the, in real world applications, where we are going to use the concept of a mathematics. That is why mathematics says it helps in logical thinking and problem solving, as I said earlier, and used in algorithms and data structures, and it is essential for fields like machine learning, graphics, and cryptography and all. So I think madam has given previous session, madam has given what you meant by machine learning and all, and you are aware of graphics, and cryptography is the new term that you may not aware of. So cryptography is nothing but, so if you want to communicate with your friend through message, so whatever the message you are being sent from to you to your friend, that should not be read by any other person. If you want to keep that one in an encrypted way, so only that will be read by your friend. Then we are going to convert plain text to a unreadable text, that we are going to call them as a ciphertext. That process we are going to call them as a cryptography. And where we are going to apply this mathematics in real time is nothing but, if I want to develop a game development, then the mathematics are nothing but geometry you are going to apply, and linear algebra, whatever you have been learned in earlier classes, you are going to use over there. And you are aware of web search engines. I think Google is the best web search engine, we are going to say. So if I want to go for the particular one, again, the graph theory falls, again, you are supposed to use the concept of a graph theory. So where the graph theory, again, it will be related with the mathematics. And as I said, cryptography. So there we are going to use the term called data encryption. There you are going to use the concept of a number theory. And especially number theory in data encryption, we are going to use a prime number concept. As we are aware of, what do you mean by prime number and all. So the same concept we are going to use for the data encryption and all. So the core concepts that I'm going to discuss here is nothing but sets and logic, the number systems, and matrices and linear algebra, and graph theory, and probability and statistics. These are the very, very important concepts that you must have a fundamentals of this particular one. Then only you could be able to become a good programmer. So as we have, when we are learning from second class onwards, we are start learning with mathematics. So set. So what is the definition of a set? Simply, we could able to say it's a collection of distinct objects. So what is that will be enclosed with the curly braces, that we are going to say it's a set. So what are different operations that we are going to perform on set is nothing but, you could able to apply union, intersection, and complement. All these are the operations that you are going to perform on the sets. So if I have been taken two sets, 1, 2, 3, and ABC, if I have performed union on these two, so what I could able to have is nothing but, the ultimate answer for the particular one is, it is going to combine. That is 1, 2, 3, ABC. That is a complete set that we are going to have. When you are going to apply intersection on the example which I have been given, that is what you are going to have is nothing but, intersection is nothing but, what you are going to have, it's any of the common term that you do have, that it is going to extract. But in the given set examples, it doesn't have any common term. That is, we are not going to get anything. It's a null set that we are going to have. So complement is nothing but, we are aware of, complement is nothing but 1 minus the particular one that we are going to have it. And the complement is nothing but, if I have been given a set of numbers 1 to 9, and I have been given the complement of 1, 2, 3, that means we are going to exclude 1, 2, 3, and the rest of the things that is going to get displayed over there. Next, we are going to talk about logic. I think you could able to follow me. If I'm going faster, then let me know, so that I could go a little bit slower. Could you able to follow me?
Yes, ma'am.
Ma'am, is this faster, or I could go
It's
for
okay, ma'am. Okay, ma'am.
No issue, right? Okay, thank you.
Yes, ma'am.
So here we are going to talk about a logic. So here we are going to talk about our propositions. That is, what a logic is always realized with is nothing but. So when we are going to make the statements, we are going to check whether the statement is true or false. So that is, if I said, tomorrow is a holiday, will you trust on me? So then you are going to check. So why tomorrow is a holiday? So as there is nothing is there, that's why you are going to, you are going to check whether the statement has been given by me, whether it is valid or not. If it is valid, then you are going to consider that one as a true. If it is not, then you are going to consider as a false. When you are going to do the particular one, always you will have some evidences or supporting things that you are supposed to have. You are going to check with that particular one. So what are the logical operators that we are going to use is nothing but the basic operators that we are going to use is and or not. These are the basic operators that you are going to use in a logic.
Madam,
And I think you are aware of truth tables. So
Bindhu ma'am.
that is which always you evaluates the logic. End gate, or gate, not gate. So when you are going to use the logical operator and, that means if the both statements are true, then only it will be a true. If the both statements are true, then only we are going to consider that statement is true. So when you are going to apply the operators, always there are two types of operators that we are supposed to talk about: unary and binary. Unary means a single operator. So you are going to apply on with a single operand. If it is you are going to apply other than unary, binary is nothing but you are supposed to have two operands. So operator and operand. Operator is nothing but and or not. Those are the logical operators. And operands are nothing but sun rises in the east.
Madam, am I audible? Bindhu ma'am?
Yes, ma'am.
Ma'am, slides are not moving, ma'am.
I'm not giving the slides, madam. Simply I'm explaining. That's it.
Okay. Sorry, ma'am.
Okay. So logical and, logical or, and not, these are the operators that we are going to have, and the truth tables that we are going to evaluate, that you are going to, I think we are going to learn that one in the upcoming sessions. So as I said, numbers and the number system always plays a vital role. So here in number systems, we do have the decimal number system, we do have a binary number system, we do have a hexadecimal, octa, we do have different number systems you do have. So in decimal system, you do have the base number. So the base 10 is nothing but it is the decimal number. That is the digits that it starts from 0 to 9. If it is a binary system, it do have only 2, 0 and 1. So this will be understood only by the system. So the base 2 number system is used by the computer. It's made up of only zeros and ones. Decimal number system that will be used in a daily life. Wherever you are going to use the numbers with the 0 to 9, the combination of 0 to 9 numbers only we are going to use in our daily life. When it comes to the hexadecimal number, it's a base of 16 system. It is from the 0 to 9 and the letters from A to F you are going to use in a hexadecimal systems. As I said, that a binary, that base 2, that is used in computers, zeros and ones. Decimal is nothing but base 10. In everyday life, we are going to use that particular one. And apart from hexadecimal, you do have the octal, that is nothing but a base 8. And hexadecimal is nothing but a base 16. These are the main number systems that you do have: base 2, base 10, base 8, and base 60. And conversion, how you are going to convert a binary decimal to the octal and binary to decimal, that if time permits, then I'll explain you. So before going for in-depth to the particular one, so first of all, you must understand what do you mean by a bit and what do you mean by a byte. All these things we must know. So bit and bytes are we could able to say those are the units, are the fundamental concepts that we are going to use in computing and digital communications. So bit is nothing but a binary digit. You must know this particular one. Bit is nothing but a binary digit. That is the smallest unit of data in a computer. So it always representing the binary values either with 0 or with 1. So the role of this particular one is mainly it is used to store and process the information in a binary format only. So whenever you are going to use in digital communications, we are supposed to use this one with a combination of zeros and ones only. When it comes to the byte, it is a group of 8 bits. Bit is nothing but either 0 or 1. We are going to call them as a bit. And byte is nothing but the group of 8 bits. We are going to call them as a byte. A byte is typically represented as a single character, such as a letter or a number in text systems like ASCII. So always you are supposed to, when I think in your curriculum you don't have C, you are started learning with Python. If you are learning with C, then you may know ASCII codes and all. So ASCII is nothing but American Standard Code for Information Interchange. So there are some predefined values that they have been specified in ASCII that will be there with the particular one. So we could able to say a byte is the standard unit for a memory size in our modern computers. Apart from that, we are going to use large units of data. That is nothing but kilobyte. 1 kilobyte is nothing but 1024 bytes, and megabyte 1024 KB, and gigabyte is nothing but 1024 MB. 1 terabyte is nothing but 1024 GB, and petabyte, exabytes. We do have different things. So all these are the data measures that we are going to use. The base one is nothing but a bit, byte, later on kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte. All these are the combinations that we are going to use in daily life. So when we are going to talk about them, so nowadays everyone is having your internet. If someone asks, so what is the, I mean, how much of Mbps that you are going to get it? So you are going to say that is 10 Mbps, 100 Mbps. So what do you mean by that particular one is nothing but a megabits per second that you are going to have. So what do you mean by megabyte? Megabyte is nothing but 1024 KB is nothing but a 1024 KB is equivalent to 1 megabyte. So kilobyte per second is nothing but kbps, and mbps is nothing but a megabits per second. And these are the measures that we are going to measure. That these are the measures that will be used for measuring the data transfer speed. So 1 byte is equals to 8 bits. 1 mbps is equals to 0.125 mbps in megabytes per second. And as we are talking about number systems and number logic, next we are going for a logic. So simply what we could able to say is nothing but as a logic is greatly concerned with the verification of reasoning. Always logic, where it will relies is nothing but it always relies with the reasoning. So when we are going to say this is going to happen, so then we are going to ask how well it is going to happen. What is the reason that it is, what is the reason behind that particular one to perform this particular operation? And okay, logic, when we are going to perform a specific logic, always it will be meant with the reasoning. If you are supposed to provide a specific reasoning, then only this will be get validated. So that is when a given set of statements have been given to us, always we are going to validate validate, and from that validated information, we are going to draw the conclusions from the given statements. That we are going to call them as the, I mean, how you are going to come to the conclusion is nothing but you are going to perform some logic. You are going to apply your logic on the particular one to draw the conclusions from the given set of statements. So simply what we are going to say is nothing but logic is independent of any other language that is associated with the set of the arguments. As we are going to say, humans, I mean, we are blessed with the God that we are intelligent than any other creature on the particular earth. So humans are the humans are the most intelligent one. That's why we do have the natural intelligence. The systems doesn't have the intelligence. That's why we are going to use the term called artificial intelligence. That is, whatever the intelligence that is there with us, we have been given that intelligence to the system. So that will mimic like as us. So you got my point. So natural intelligence resides with the human only. Human or the God created creatures, only the God created creatures have the natural intelligence. So the missions have been invented by the human. So will they have their own intelligence? No, that they doesn't have own intelligence. The humans, we are giving our intelligence to the system. That's why we are going to use the term called artificial intelligence, which is not a natural intelligence. Whatever the information or whatever the intelligence that we are carrying, we are giving that information to the system. That's why we are going to call that one as the artificial intelligence. So that's why humans will have the more ability to sense of mind. So when I'm going to do something, so for suppose when I'm delivering a lecture, in meanwhile Hema madam has interrupted me. Madam, the slides are not getting changed. So then I'm going to, I'm going to receive the instruction, whatever been given by her. Accordingly, I have been responded to the appropriate one. So, madam, they haven't been, there is no specific templates are there to transfer. Just I want to share the slides. That is the information that I have been shared with them. So that's why my sense of mind is there and could able to explain. So what are the conclusions that I could able to draw is nothing but based upon my sense of mind. The sense of mind I could able to call them as a logic. So that is nothing but logic provides the shape to the sense of mind, and logic that outcome the sense of mind. So where it is nothing but it simply have the logic always deals with the validity statements. From the validity statements, it is going to collect all the valid statements and it is going to generate some specific conclusions. And by using that conclusions, it is going to generate a specific thing. And before going to the particular one, so arithmetic operations that we are going to use is nothing but addition, subtraction, multiplication that we have been learning from the childhood to till now we are applying. Addition, that is nothing but a fundamental operation that it is used for combining 2 or 3 numbers to find their sum. As we are aware of, subtraction is nothing but a difference between 2 numbers, and multiplication is nothing but it is going to the repeated addition that we are going to call that one as a multiplication, and you are going to use arithmetic operators that is nothing but division or modulus, all these things that you are going to use in a computer programming too. And after that, we are going to have a Boolean logic and linear algebra. So Boolean logic and algebra, where it is there with. So when we are talking about a Boolean logic will always with the Boolean logic. So logic always relies with the true or false, 0 or 1, whether it is true or not. So how we are going to check this particular one? And there we are going to use some logical operators called and, or, not. These are the logical operators that we are going to validate whether the statements are true or not to draw the conclusions from the given statements. So later on, we are going to talk about matrices and linear algebra. So matrices is nothing but a rectangular array of numbers. That is, array is nothing but the homogeneous elements that we are going to call them as an array. We could able to say a matrices is nothing but a 2-dimensional array is nothing but a matrices. And generally, the number system we do have scalars and vectors. Scalar is nothing but a single valued one that we are going to call them as a scalar, and more than one values that we are going to call them as a vector. And we could able to say matrices is a vector. When comes to the array is nothing but a homogeneous elements that we are going to specify it. So matrices is nothing but 2-dimensional vector is nothing but a matrices, or 2-dimensional array is nothing but a matrices that we are going to specify it. So where you are going to apply this matrices is nothing but, so transformation in computer graphics you are going to have, and solving the linear equations there also you are going to use matrices and linear algebra concepts. Apart from that, as we want to become a computer programmer, we must know the concepts of numbers and variables and the data types and all. So numerical representations that we do have is nothing but we do have a binary. As I said, there is a binary. Binary is nothing but 0 and 1. Decimal is nothing but 0 to 9. Hexadecimal is nothing but 16, base 16, and octa is nothing but base 8. All these number systems that we must aware of this particular one, and we must know how well it is going to convert. As I said that a computer cannot able to understand the high level language, then what it has to do is it has to convert high level language to a low level language. A low level language must be in the form of zeros and ones. So if any decimal number has been given, that is 10, then how we are supposed to convert is nothing but you are supposed to convert 10 to a base number. That is the equivalent of conversion from decimal to the binary. If time permits, I'll show you how you are supposed to convert a decimal to the binary. And we are going to talk about variables and data storage, and that is nothing but when you are going for in-depth of the as in previous class madam has said, here we are going to feature feature selection or feature extraction. When she used the term called in machine learning, you are going to use the term called features. In programming languages, in data, in DBMS, you are going to use the term called variable. So what do you mean by variable? Variable is nothing but it always stores the values which varies. It's not a constant one. It is going to get changed. And understand various data types. That is nothing but what are all different data types that you are going to have is nothing but we do have the integer data types, and we do have a floating point data types, and we do have the strings. So what do you mean by a string? When we are talking about if you want to define a language, simply we could able to say a language is nothing but set of strings. What do you mean by a string? A string is nothing but set of characters. What do you mean by a character? Character is nothing but a simple simple symbols that we are going to call. So how we are going to define a language? Language is nothing but a set of strings. A string is nothing but a set of characters, and character is nothing but a special symbols that we are going to call. So all these things that we are going to use here. And as I said, arithmetic operations that we are going to have is nothing but addition, subtraction, multiplication, division, a logical and logical or, all these things that will be used for the problem solving, programming algorithms and problem solving. There you are going to use. Again, the things, variables, data types, and finally we are supposed to have the naming conventions. Naming conventions are nothing but, so what you are supposed to have is so we are supposed to make our data in a readable format, and you are supposed to convert a data into a required format, that is transforming a data into a required format, that we are going to call them as the naming conventions. And as I said, the numbers will be the integers, floating point, and binary. So integers are nothing but a whole number. Both the positive and negative numbers, we are going to call them as an integers. And comes to the binary representation, we could able to say it's a combination of zeros and ones. Zero is one bit, and one is another bit. So byte is nothing but 8 bits is nothing but 1 byte. And floating point is nothing but it is a numerical value that can be represented in a fractional part. That is nothing but 1.07. That is a floating point number. Next, we do have arithmetic operations like addition, subtraction, multiplication, divisions, all these things that we are going to use with. So these are the symbols that we are going to use, the same things that we are learning from our childhood to till now, the same things that we are going to have it. So arithmetic operators that you are going to use, logical operators like and, or, not, are the logical operators that you are going to use for making the decisions. Whether the statement have been given by us, whether it is true or not, then we are going to check with the logical operators, that is and, or, not. And relational operators that we are aware of, nothing but relation. What is the relation between one operand to the another operand? Then we are supposed to have the relations. That is nothing but lesser than, greater than, equals to, less than or equals to, greater than or equals to, all these things. We are going to use the same things what we have learned in earlier classes. The same concepts we are going to use in computer programming too. And when you want to become a computer programmer, then you are supposed to know what are the different conditional and control structures that we do have. Conditional statements and the loops. So when we are going to have, if you have been attended today, then you are going to get the certification. As the madam has announced that you are supposed to give your, after the sessions, completion of these sessions, you are supposed to go with the feedback form, and you are supposed to give your quiz attention. Then only you are going to get your certification. Otherwise you are not going to get. There what we have used, if you did this particular one, then only you are going to get your certification. That, so if these conditions get satisfied, then only you are going to get the antecedent and a precedent. So if this if this was to happen, then this should happen, then only you are going to get certification. That is nothing but if this happens, then this. If not this, then no. That is what logic there with. So in the computer programming also, we are going to use the same thing. That is nothing but if and else. So we are going to say if and else and loops and switch statements. All these are nothing but the conditional and the control structures that we are going to have. So if and else is nothing but a conditional statement that it will be executed on a different paths based on a specific conditions. And when comes to the loops, loop is nothing but it is a repeated execution of a code. It is a repeated execution, the same thing that you are going to do. That is nothing but a loop that you are going to have it. So we could able to say in a iterative problem solving, we are going to use the concept of a loop. And switch statement is nothing but if this is not going to get happen, you are going to switch to something else, then we are going to use that is nothing but a switch statement. Simply what we could able to say is nothing but in real life how we are going to use the same thing that we are going to apply in a programming language too. And the control structures, where as I said earlier that the control structures will have the sequences and selections, and finally you do have the iteration. So what it includes in sequence is nothing but it executes the instructions in a way, in a specific order that have been written in a specific order. So a sequential manner, in a sequential manner everything is going to get executed, that we are going to call them as a sequence. And selection is nothing but whatever is apt for this, that you are going to choose, that we are going to call them as a selection. It is completely based upon the condition. If this condition gets satisfied, for example, when you have been written your final exams, you are going to get grade. So if you acquired 90% and above, then you are going to get a grade called S. If you got 60 and above, you are going to get a grade called something. So that is what a selection. If this condition gets satisfied, this is the grade point that you are going to get it. That is nothing but a selection. And comes to iteration. Iteration is nothing but it is going to have repeating a set of instructions until it reaches to a specific thing, that we are going to call them as a iteration. And if there is a specific condition is there, if you meet to the specific condition, you are going to repeat that process until it gets satisfied. That is nothing but an iteration. So I think you understand the difference between sequence, selection, and iteration. Sequence is nothing but the process that you are supposed to have. The first step that you are supposed to do this particular one. After first step, you are supposed to go for the second one after the third one after the fourth, until it reaches to the final one. That is nothing but a sequence. And comes to the selection is nothing but, so based upon the condition, whatever the condition gets satisfied, you are going to simply switch over to the particular selection process and you are going to come to the conclusion. That is what a selection is. And iteration is nothing but until reaches to the specific condition, you are supposed to repeat the same set of instructions, repeating the same set of instructions to reach to the certain goal. That we are going to call them as iteration. So loops and iterations, you do have the while loop, for loop, do while loop, nested loop, different things that you do have. That is nothing but in while loop, what it is going to have is nothing but in while loop, the repeated. So first of all, there we are going to know, it is not going to check the condition. First of all, it executes the block of code. Later on, it will check the condition. And for loop, if all the conditions are getting satisfied, then only it is going to have. This is the best example for iteration. For loop is the best example for iteration. And comes to the nested loop, that is nothing but it's a, when you are going for a multiple loops within the same thing, then you are going for the nested loop. It is a combination of for and while and do while. It's the nested loop. So whatever it is, what till now we have been learned about number theory and linear algebra, and where you are going to apply the operators like relational operators, logical operators, and control and conditional statement. It always have to work with the problem solving. So why we are talking about this mathematics and computer science is nothing but our motto is to provide a solution to the specific problem. So that is nothing but when problem is there, how you are going to solve a problem. That is our motto. So when we are going to solve our problem, so what are all different steps that we are going to follow? That we are going to call them as an algorithm. Right? So problem solving always meant for, so when a problem is there, you are supposed to provide a solution. So that process we are going to call them as a problem solving. So how we are going to provide a solution with the help of a specific procedure. That procedure we are going to call them as an algorithm. So algorithm is nothing but sequential steps that we are going to follow to provide a solution to the particular problem. So first of all, if I want to provide a solution to the burglar problem, first of all, what I'm supposed to do is I must understand what exactly the problem is. Then only I could able to provide a solution to the burglar one. So when a problem has been given to you, what you are supposed to do is you are supposed to understand what the problem is. So that's why you are supposed to have clearly define the problem and identify the desired outcomes, what exactly you are going to expect from the burglar one. Later on, you are supposed to develop a plan. So whether you are going to do everything at a time, or I'm going to divide that one into your different blocks to make that problem as easier one to get in a, in a proper way or not. That is what nothing but a developing a plan. Once it has been done, then what you are going to do is nothing but you are going to implement a solution by using any of the programming concept. By using any of the programming concept, you are going to implement the solution. Once it has been done, then you are going to test whether whatever I have been done with, whether I could able to reach to a certain goal or not. You are going to test by yourself. Once it has been done, then you are going to keep that one outside so that others could able to understand. So when we do have I think you could able to understand algorithm. Simply an algorithm is nothing but the sequential steps that you are going to follow to provide a solution to the burglar problem. So that we are going to call them as an algorithm. Algorithm includes the techniques. Algorithm always includes the techniques. So when we are going to talk about an algorithm, algorithm always have the input as well as an output. So algorithm always must have the input as well as an output. So based upon the output also, we are going to change the steps. So that's why algorithm always includes the input and always algorithm must have the input and as well as the output. Then only you are going to have a proper steps to provide a solution to the burglar one. That we are going to call them as an algorithm for problem solving. And so what do you mean by recursion? In recursion and problem solving is nothing but we are supposed to understand what do you mean by a recursion. Recursion is always plays a vital role when you are going to talk about a programming concept. So recursion and iteration are two different terms. So understanding recursion is nothing but, so when we are going to talk about a function, it calls by itself, that we are going to call them as a recursion. And what do you mean by recursive problem solving is nothing but, so if I want to solve the complex problems, so simple problems we could able to solve easily. So I think you are aware of the term called Fibonacci series. Fibonacci series, how we were going to have, I think we could able to compute factorial of a given number. So how we are going to calculate the factorial of a given number? If 4 factorial is there, then how we are going to calculate 4 factorial is nothing but, how we are going to calculate the 4 factorial? 4 into 3 into 2 into 1, right? So when it is going to have n factorial is nothing but n into n minus 1 factorial. N minus 1 factorial is nothing but n minus 1 into n minus 2 factorial and so on. So that is, if I want to calculate 4 factorial, what we are going to do? 4 into 3 into 2 into 1. That is completely a sequence of, it's a simple loop that it is going to have. When it comes to the recursion, if I want to generate a Fibonacci series, then I'm supposed to use the concept of a recursion. What do you mean by recursion is nothing but calling the same function by itself, that we are going to call them as a recursion. So where we are going to use the concept of a recursion? When we are going to solve the problem of a Fibonacci series, if you want to go for a towers of Honai, there you are supposed to use the concept of a recursion. So can't I, without using a recursion process, can't I able to find a solution? And yes, you could able to find a solution, but it will take much time. Rather, if you have used the concept of a recursion, we could able to do that particular with a simple way. That is why we have been taken a concept of a recursion process. So as I said, recursion and iteration are two different terms. Here we are going to see the difference between. So recursion and iterative problem solving the techniques, they are going to use how well they are going to use the particular one. Here we could able to see. So a recursion is nothing but a problem solving technique where the function calls itself to solve the smaller instance of the same problem. So same problem ni use chesukodaniki, there you are supposed to use the concept of a recursion. When we are going for the iteration, it is the repetition of a process or the set of instructions to a certain number of times until a condition is going to get met. That we are going to call them as an iteration. Better not to get confusion among recursion and iteration. Iteration is nothing but set of repetition process that we are going to do. That is nothing but set of instructions for a set of number of times that you are going to meet. That is nothing but an iteration. When it comes to the recursion, is nothing but the same thing, the same function it is going to call by itself. That function that is going to call the same function itself, that we are going to call them as a recursion. And simply we are going to use the term called trade-off. Trade-off is nothing but recursion can be more expressive than iteration. So which one is better one? And simply we could able to say, if you use the concept of a recursion, we could able to explain it clearly. When it comes to the iteration, we can't able to do the more efficient way, we can't able to do the particular one. So when we are going to talk about algorithms, always we are supposed to talk about along with the pseudocode also. So algorithm is nothing but, as I said, it is a simple step-by-step process or step-by-step instructions for solving any problem. And pseudocode is nothing but, it's a high-level description of an algorithm. We are going to say it's a high-level description of algorithm using a mixture of natural language and programming constructs. It's a natural language as well as the programming constructs that we are going to use to define the pseudocode. Algorithm is completely high-level language program that user could be able to understand well. We are going to write it as algorithm. And comes to the pseudocode. Pseudocode is a combination of a natural language as well as the programming constructs. We are going to call them as a pseudocode. And once the algorithm and pseudocode has been written, then we are supposed to use the term called efficiency. So what do you mean by efficiency? There we are going to calculate the efficiency in two ways. One is time complexity, second one is the space complexity. What do you mean by a time complexity? Is nothing but within a time period, how much time period, if a problem has been given to you, how much time that you are going to complete that particular problem, that we are going to call it as the time complexity. And space complexity is nothing but how much memory is required to do the particular one, that we are going to call them as the space complexity. So whenever you have been written a program, you are supposed to go with two complexities that you are supposed to calculate. One is the time complexity, second one is the space complexity. And time complexity and space complexity must be a minimized one. Then only we could be able to say you have been a good programmer. So when we do have a problem solving strategies and algorithms and problem solving strategies, what we are supposed to have is nothing but, so first of all, you must have the algorithmic thinking, and after that you are supposed to perform some sorting and searching techniques, and later you are supposed to go with the recursion and iterations that we have been discussed earlier. Madam, can I go with it?
Yes, ma'am. Yes, ma'am.
Time is not running out.
Yeah,
So
yes, ma'am. It is running out,
there.
ma'am.
So as I said,
Students are
that
requesting.
complexity analysis, you do have a time complexity and space complexity. When we are going for in-depth of a computer programming, then you are going to talk about big O notations and all. If time permits, in next, if university authorities are going to conduct next session, next series of this particular one, then we could able to understand how we are going to analyze big O notations and all. And I must give a glimpse of data structures and abstractions. So generally the data structure, the structure of a data. So how you are going to store the data. So storing of a data is one thing. Once a data, to which data we are going to store, the useful data only we are going to store. So what are the operations that you are going to apply on the data is nothing but modification of the data, removing of the data, adding of the data. All these are operations that we are going to perform on the data. So the data structures, there are two types of data structures that we do have. One is the linear data structure, next one is the non-linear data structure. What will comes under linear data structure? In a structure line, in a line format, that we are going to call them as a linear data structure. If the tree structure or a graph structure format, if it is in the form of a tree or a graph structure format, then we are going to call them as a non-linear data structure. So, in spite of going for the linear and non-linear, we do have different data structures. We are supposed to have is nothing but arrays, linked lists, stacks, queues, trees, and graphs. All these are the combination of linear and non-linear data structures. And finally, what I'm trying to say is nothing but mathematics are the foundations that are always crucial for effective computer programming. And mastering on these concepts will always set you up for the success. And final thought I want to share with you is nothing but don't be afraid of mistakes. They are part of learning. Ask questions, be curious, and be enjoy the process of discovery. Remember that mathematics is not about getting the answers right immediately. It's about learning how to think throughout the problem is. Thank you for patience listening.